All right, let's talk about combining like terms. Before we get into the actual process of combining like terms, let's talk about the parts of an expression. This right here we call an algebraic expression. An algebraic expression is an expression that contains variables. And if we look at this expression, we have various terms that have variables. Now, what is a term? A term is just a part of an expression that is separated by an addition sign. So this would be one of our terms. This would be one of our terms. Negative 5x would be one of our terms because that's the same thing as saying plus negative 5x. 8 would be one of our terms. 4x would be one of our terms. And then negative 1 would be one of our terms because that's the same thing as saying plus negative 1. Okay? These are all of our terms. Now, when we're looking at our terms, some of our terms have a variable, and we call these variable terms. In this particular algebraic expression, our variable terms are 7x, negative 5x, and 4x. We also have some constant terms. Our constant terms are terms that do not have variables, terms without variables. So in this particular example, we have 3, 8, and negative 1. Okay, now how do we combine these variable terms? How do we combine these constant terms? Let's start with the variable terms. With the variable terms, we first need to make sure that the terms in question have the same variable raised to the same exponent. So if you look at these three terms, we have 7x, negative 5x, and 4x. They all have the same variable, x, raised to the same exponent. Okay, so we are going to be able to combine them. How would we combine these terms? Well, we would need to look at their coefficients. What is a coefficient? A coefficient is just the number that's next to a variable term. So in this particular case, our coefficients are 7, negative 5, and 4. When we are combining like terms, because all of these are like terms, they all have the same variable, all we would do is combine their coefficients and then put the variable that they shared back on there. We wouldn't change anything with that variable. So all we would do is 7 plus negative 5 plus 4. And the reason we could do this is because of the distributive property. And I'll show you why in one of my next examples. But 7 plus negative 5 is 2, and 2 plus 4 is 6. Okay? So this would be 6, and then we would add the x. Okay, because the x stays the same, that's part of all of those terms. We could write it also like this: 7x plus negative 5x plus 4x is going to be equal to 6x. We just add all of those coefficients, 7, negative 5, and 4. Now with constants, all you would do with your constant terms is add them. They don't have any variables, you would just add them. So I'll do that in green here. We have 3 plus 8 plus negative 1, which is 10. So this final expression, if we combined all the terms, all the like terms in this huge algebraic expression, we would be able to condense this huge algebraic expression to 6x, and this is a positive 10, so it would be plus 10. And that's how we would combine like terms. So pause the video, write this down, read it, but basically we can simplify an expression by combining like terms. We combine common variable terms and we combine constant terms like we did in our previous example. This is from our previous example. And when we combine like terms in this previous example, we wound up with 6x, I believe it was plus 10. And that was our answer when we combined all this junk. Why? Because we were able to combine this 7x, this negative 5x, and this 4x. That gave us 6x. And we were also able to combine this 3, this 8, and this negative 1, and that gave us 10. Now, when you are combining like terms, you need to make sure that not only do they have the same variable or variables, but they also are raised to the same power. So if we look at this example, we have a squared plus 7ab minus 10ab plus b squared. So what I like to do is I like underlining, and if you have different colors, you can underline them with different colors. I'm going to underline this a squared. And I'm going to look through this algebraic expression to see if there are any other terms that have an a squared. Now this term has an a, but it also has a b, and plus the a isn't even squared. So that would not be a like term with a squared. Here we have a square, but we have a b squared. So that would not be a like term with b squared. So there is no like term with a squared. Here we have an ab. If we scan this algebraic expression, we could see that we have another term here that also has ab. Both variables are the same and both are raised to the same power. So we are going to be able to combine these two terms that are in green. And then last we have a b squared. If you scan through this algebraic expression, you would see that there are no other b squareds on here. So how would we combine these like terms? We would just look at their coefficients, which in this case is a positive 7 and a negative 10, and we would add them. Okay, positive 7 and negative 10. I'll do that on in the side here in this little rectangle. If we have positive 7 plus a negative 10, you are adding two integers that have different signs, so you subtract. That's going to be negative 3. And we keep the sign of the negative because that's the bigger absolute value, so it's negative 3. So our final answer, and I'll do this back in blue, it would be a squared, and then we combine these two. So these two turned to negative 3, and then we have to put the variable back on, ab, and that's plus b squared. And that is the simplified version of this particular algebraic expression. Now remember, write this down, read it, but remember, do not change their exponents. Okay, so here's an example where we are going to have to combine terms that contain exponents greater than 1. Here we have a 4x squared and a negative 3x squared. Okay, we also have a couple constants that we're going to be able to combine, and we also have two terms that just have an x. Now, I'm going to do the red first. The red is 4x squared and negative 3x squared. When you're combining like terms, you're only going to look at the coefficients. So in this particular case, we have 4 and negative 3. The x squared part doesn't matter. All we're going to do with the x squared part is just add it back on to our term once we are done combining the 4 and negative 3. So if we do that in this little rectangle here, this red rectangle, 4 plus negative 3 is 1. So this is just going to be 1x squared, or we could just write x squared. But again, we don't do anything to the variable or the exponent. We are done with the reds. Now, if we do the greens, those are just constants. That would be negative 7 minus 6. And I'll do that over here. Negative 7 plus a negative 6. Since we're adding integers that have the same sign, we would add them and keep the sign the same. So that's negative 13. So that's x squared minus 13. We're done with the greens. And then the last one, the yellows, would be 2x and 8x. We just look at the coefficients, so it would just be 2 plus 8. 2 plus 8 is 10. So this last one is going to be plus 10x. And normally we would want to write this in standard form, so we would flip-flop the 10x and the negative 13. But the directions didn't explicitly say to write it in standard form, so we'll just leave it as x squared minus 13 plus 10x. And I told you at the beginning of the video I was going to show you why we can combine like terms, and I'll do that in the bottom really quickly. I want you to add this to your notes as well. Let's say we have 3x plus 5x. Okay. Now the reason why we can combine like terms is because of the distributive property. If you remember the distributive property, we can factor out whatever term or factor they have in common. I meant to say factor, whatever factor they have in common. So if we look at 3x and 5x, they both share a factor of x. So I can actually factor out an x, and if I do, that's going to leave me with x 3 plus 5. And if we use the distributive property back on here, you would see that x times 3 is 3x, and 5 times x is also 5x. So we'd wind up with 3x plus 5x. Now, 3 plus 5 is 8. And if we multiply 8 times x, that would leave us with 8x. And that's the reason why we can combine like terms. That's the reason why we could just say, hey, add the coefficients. 3 plus 5 is 8, and then bring back that x. But remember, they have to have the same variable or variables raised to the same power. We're going to do some more examples tomorrow. Make sure you have all this in your notes. Have a great day.